Good morning, good afternoon, or good evening, wherever you might be watching from. My name is Anand Ranganathan. I am the Chief AI Officer of Unscramble. We are a startup that's in the space of AI, and our core focus is to make data and insights easily accessible to business users or even general public who might not have had access to these kind of data and insights before. More specifically, we are one of the pioneers, I believe, in this space called Conversational Analytics, which means how do we help users get insights from data through conversations. So essentially, it means chat with the data to get relevant insights. So let's dig a bit deeper. As we all know, times are changing. So the last few months have seen a dramatic change in the way people live, play, and especially work. It's now a very commonplace for people to be working from home. A lot of work happens remotely on collaboration platforms like Slack or Microsoft Teams. And people have figured out how to be productive in these platforms. So even though the kind of mode of work has changed, people have now figured out how to effectively do their work with the aid of collaboration platforms. This is one big bottleneck that many people face though, and that is data. So it's still very difficult for users and critical employees in organizations to get relevant access to data quickly so that they can make informed decisions. Data adoption remains very low across different organizations and in fact continues to drop. So in fact, there was a survey earlier this year which said that only about 31% of organizations say that they are data-driven, which in fact is down from 37% in 2017. And there are several reasons for this. Many business users just say that it's too complex to find and access data that they need. It takes them too much time. They know where data is. If they know where it is, they don't know how it is modeled and how to query it. So they have to rely on external teams, either an IT team or a data analyst or data science team to get access to data. And oftentimes there are lots of tools that an organization might have which business users may not know how to use. So the data gets stuck in the hands of a few limited people that have the right skills, while the rest of the organization is thirsty for this data and just can't get it. So while work has migrated effectively to collaboration platforms like Slack or Microsoft Teams or even Zoom, data is still very inaccessible to most business users. There's still a very big gap between business users and the data that they need. So that's a big challenge. And in fact, that's a challenge not only in organizations, which vary from small to large enterprises, but it's also a challenge for the general public. The general public also struggles to get relevant insights from various data sets. And a perfect example of that is the COVID-related data. So ever since the pandemic started in February or March of 2020 this year, different organizations have made available pretty rich and interesting data sets. So there's a data set from Johns Hopkins, a data set from New York Times, one from Wall Street Journal, and all these data sets are maintained and updated very frequently. In spite of all this, most people are not able to access these data sets directly, at least. So they rely either on pre-built dashboards or pre-built charts or graphs, or on opinions or other articles that people might be writing based on their own analysis of the data sets. So most people have no way to actually manipulate or handle these data sets to get any insights that they need, and they rely on other people to be able to get further insights. So that's obviously a challenge. And in general, getting insights from just pre-built dashboards or reports is a problem. Most dashboards do not offer sufficient drill downs, so they might present information at a high level, but it may not be possible to drill down by some aspect or metric or dimension that somebody might be interested in. Also, most people may not know how the data for the dashboard is actually produced. So this results in some lack of trust in some cases about the data. One fundamental point of most charts or databases or dashboards is that they answer a very specific question. So if you want to ask a different question, though, that may not be answered on the dashboard. And finally, a big challenge is that all dashboards and charts are actually representative of an opinion. So it's actually made by some person who might have his own implicit bias or agenda. And it's very easy to manipulate a chart or a dashboard to portray some other fact or some other insight than what might actually be present in the data. And this can be used for misleading the public or enterprises as well. So I'd like to show a couple of examples of that recently. So a few months back, there was a chart doing the rounds in various media outlets saying that the US was doing an amazing job in controlling the pandemic. So, for example, this was a chart that was shown, which said that the US had one of the world's best rates in terms of a metric called observed case to fatality ratio, and it's better than all the countries except for Germany. So that was used as a proof to show that the US is doing a pretty good job. However, that dashboard or that chart is actually quite misleading. As it turns out, the metric that they used, observed case to fatality ratio, is not really the ideal metric to determine if a given country is doing well. A better metric could be something like deaths per 100,000 people or per capita deaths. And if you take that metric, the US is like among the bottom 10 or 11 of all countries as of this chart. This is about in April or May of 2020. So this is one example where somebody can just cherry pick data, compare a given country with just a few selected countries, and use a slightly obscure metric to make a point that the country like the US is doing a great job, when in fact it may not really be the case. Another example, quite recently, this is a graphic that is doing the rounds in Instagram, Facebook, and other channels recently. It said that this is actually from April 2020. So according to this graphic, about 10 different democratic states had much higher cases and deaths than 10 other Republican states, which had much fewer cases and deaths, even though they had the same population. And the conclusion was that Democratic-run states were incompetent medically. However, there are a bunch of falsehoods in this chart. So one of the states that was supposedly Democratic actually had a Republican governor. And in fact, the actual numbers are wrong. So the Democratic states actually had fewer cases and deaths, but the Republican states actually had more cases and deaths. And there were a bunch of other points that are not made clear in this chart. So for instance, there was significant underreporting of cases because of lack of testing overall. And also this chart made the mistake of conflating correlation with causation. So just because democratic states had high cases and deaths doesn't mean it's because they were democratic. In fact, density and demographics, like number of people from different backgrounds or travel abroad, were better predictors than just politics. So in fact, Facebook after a while labeled this post as false and it stopped being distributed. But damage could have been done in the few weeks that was actually being distributed in different social media outlets. So those are a couple of examples of charts that have been created in fairly misleading manners, and just illustrates the problem with just relying on dashboards or charts to get your insights. And we really need ways to allow people, this could include general public, but also users and enterprises, to get access to the right raw data as much as possible so that they can play with the data themselves and uncover their own facts and insights. So the solution is to get more power to the people and let the people play with the data themselves. How do we do that? It's a challenge, but one approach that we think is very promising and one that we believe we're one of the pioneers of is conversational analytics. So conversational analytics is a paradigm by which a user might ask a question or a query in natural language. This query can go against one or more databases, and then the system provides responses, again in natural language or in charts, to explain the data and to provide some insights on the data as well. And furthermore, conversational means that the user can further refine those questions and dig deeper, just as they might do in a conversation. So in any given conversation between two people, there's a context, and people can dig deeper into their ideas and thoughts, and finally reach a conclusion, as opposed to a dashboard, which is more like a sermon that somebody might just be providing to somebody else. So that's sort of the main belief, that sort of the main idea behind conversational analytics. And in fact, Gartner predicts that very soon a large number of analytical queries are going to be generated using natural language or voice. So this is the beginning of a major trend, we believe, in business intelligence and data analytics and reporting. To make this happen, though, a bunch of technologies need to come together to allow people to ask questions or queries in natural language. So there's natural language understanding needed, so as to convert any natural language utterance that the user makes to a relevant SQL query or query in any other formal language that can go against the database. And the challenge there is that this query the SQL query must be tailored to the specific database. So different databases will have different schemas, different sets of tables and attributes and entities and relationships within them. And the translation process, translation of natural language to SQL, must take into account the schema of the database as well as the values presented to the database. So that's a challenging problem because the variety of databases are endless. We also need machine learning to automatically figure out what are the right kinds of insights to extract from the database for any given question the user might ask. Automated insights are useful to again extract relevant insights in a personalized manner that is relevant to a given user. And finally, there's also a big challenge in automatically visualizing and explaining the data returned from the database in a manner that is understandable to the user. So there's so much challenges in conversational analytics. But one of the big benefits is that if we are able to do conversational analytics, then it means that people can potentially start chatting with the data on platforms like Slack, Microsoft Teams, or even public chat platforms like even Facebook Messenger or WhatsApp. So that's the idea behind conversational analytics. So we want to move from an old world or a current world where most users complain that they don't have access to their own data and it takes them days to get answers to even simple questions, to a new world where people can get insights by just asking for it. So in this new world, every user would have a personal AI-powered data analyst that will know how to answer their natural language questions on the data. And this is where we want to introduce Cubo. This is our take on conversational analytics. So where each user would have a personal AI-powered data analyst that can understand the natural language questions and figure out how to get those answered from the databases that they have access to. So people can ask questions like, why have sales dropped in a given month? What's the predicted sales in the next 15 days? Show me a trend of sales by time of day. Or, hey, Cubo, what's the response for a certain kind of promotion, a marketing campaign from the last month and so far? So those are questions in natural language that we want the system to be able to answer immediately. In fact, there are lots of, this is a universal problem that spans different industries, different roles, different kinds of questions. There can be questions in supply chain, questions about revenue. So for instance, what's the predicted order volume from New York City for the next 2 months? Notice that these questions can use slang, can use abbreviations like NYC, can use all the other artifacts as well as challenging parts of natural language and the goal is the system should still be able to handle them and make sense of them. Other examples from fraud detection, risk management, marketing. So, for instance, how many cash transactions are made by customers in New York, or what's the average lifespan for men in West Virginia in the coal industry. So all different examples of natural language questions that people might want to ask in different industries. So at this point, I'll switch over to a demo so that you can get an idea of how, of what our vision of conversational analytics looks like. So this is a demo on a coronavirus, a COVID-based data set that has information about deaths, hospitalizations, negative cases, positive cases, and other such metrics for different parts of the US. So as soon as I log in, I get information about what are the top questions people have been asking and who have been asking questions. And I can start chatting with the bot, whose name is Cubo. So let me start a new thread of conversation and say US COVID analysis. So this interface resembles interfaces, other chat-based interfaces like Microsoft Teams or Slack. And what it does is you can create different kinds of threads, and in each thread you can have your own conversation with the data. So let me start asking a few questions on the data. So I can start by saying things like total deaths. So when I ask a question like total deaths, the system will automatically figure out how to interpret that question. It will convert it to a SQL. So this can come back with a response that it gets from the database. It further provides some other clarifying information about the data set and, for instance, the range of data available. And this helps it helps the user get a context of of the answer. So in this case, it says that there were 208,000 deaths based on data sets from January 2022 to October 14th, 2020. I can further look at this in a bit more detail and get some information like the actual SQL query that is generated. So this is actually a SQL query that is automatically generated from this particular natural language query. So in this case, it gives a sum of a certain column and from certain table and with certain limits. So all that is automatically generated from the natural language query. So as I mentioned in the conversation, you can further define, so you can further drill down. So I can ask, for instance, show me by state. When I do that, it's now going to understand the context. So it knows that when I say just by state, it knows that the context is total deaths. So it's going to now show me total deaths by province or state. Province state is the specific attribute that's in the database, and it knows that state might mean it's probably mapped to province state. So I can view that, and it gives me, in this case, map the US, different states of the US, and the number of deaths in different states. So I can view that as a map, or I can view that in other ways as well. So for instance, I can view it as a table. So New York, Texas, California, New Jersey have some of the highest deaths. Let me now define further and also look at it by month. So now, so one of the things about natural language and conversations is there's often ambiguity, which means that the same term or the same query could be different in different ways. So we just say by month, it could mean a couple of things. The context is still that that I'm asking about total deaths, but now did I mean total deaths by month? So did I mean just group it by month, or did I mean further group by month? Which means did I mean give me total deaths both by month and by state? So keeping the previous grouping alive. Let me say that I want to further group by month, which means I want to do both month and state. So this is the way we resolve ambiguity by presenting different alternatives to the user so that they can figure out how what's the right question for them. So I go here and define the group monthly. So now I get the answer for each state and for each date, what was the total number of deaths. And I can do this in different ways. Again, there's a map is an option because I have it's location-based data. But it picked a table for me because it's a pretty big data set. So one of the features is that we want to be able to automatically pick the right visualization for a given data set. So in this case, the big table, but I can switch it back to a line chart, for instance. And you can see the line chart is pretty crowded. There are lots of different states being mentioned over here. So let me make this a bit less crowded and just pick a few states. So I can do that in a couple of ways. I can just deselect some states over here and take them out of the chart, but there are too many states. Or I can do this again through natural language. So I can say refine and restrict to just Connecticut, which is where I live, and let's say New York, and a couple of other big states, Texas and California. So let me do that. And now again, there's some ambiguity. Do I mean to restrict it to these states or to expand it to these states? I'm already restrict it. So I want to just pick those 4 states. And now let's see how the data looks. So it automatically came up with a SQL query in the backend. And now the map, of course, shows just those 4 states. And let's view those in a bit more detail. Let's just look at it in the line chart. And we see that the trend monthly over the last few months of how the total number of deaths changed. So there was New York had a very large number of deaths in April, but then started going down. Same as Connecticut. Texas and California had smaller spikes in April and May, but bigger spikes later on July and August. So all this is now easily accessible to me as an end user. I can create a chart, compare two states, compare them across different months, compare different metrics easily. So all this is possible quite just by through natural language and by conversing with the data. So let's do something different. Let's just focus, say a couple of metrics on just Connecticut. So let's say total deaths and total positive cases in Connecticut. So now it's going to, so that's total number of deaths and positive cases in Connecticut for the whole data set range. Let me do this monthly. Sure, monthly. So it's just only monthly. And now it's going to give a line chart. So I can compare these 2 metrics. So for instance, now I can see that in general, as the number of positive cases increased, the number of deaths also increased. But there's this interesting deviation where the number of positive cases seem to have increased in September, although the deaths did not really increase too much. So there's some interesting observations here. Apart from natural language, our specific interface also allows you to explore the data through other UI mechanisms. So let me say I want to also compare another metric, like total number of hospitalizations in this time period, just to see how that varied over the last few months. So in this case, I get a new line chart or new line with the number of hospitalizations. And as we can see, the number of hospitalizations started growing a lot in Connecticut in May, but went down significantly in June, and it's actually negative in June, which meant more people were coming out of the hospital than going in, and they'll kind of remain steady after that. So all this is again possible this conversationally. Let me go back to the secure conversation view, and let's look at different metrics. Let's say one thing which people often are interested in is positivity rate. So let's say I want to ask a question like, what is the positive case rate in the last 6 months? So over the last 6 months, which it's clear now what I meant, how the system interpreted the last 6 months, so April 1st, 2020, 2020. So right now it's October. It says that the overall positive case rate is 6.77%. Let me look at this monthly. So in this case, it's now going to do again a line chart to see how the positive case rate, and you can see Connecticut, for instance, the positive case rate was pretty high in April, went down in May and June, again a spike in July, and kept going down in August and September. So yeah, so that's the most recent. And let's say, and this is actually for the whole of the US. So let's say I want to refine and Connecticut again. So that's the whole US. I want to, okay, just restrict it to Connecticut. And yeah, so now it looks very different for Connecticut versus the whole US. So Connecticut, positive case rate in April was massively high, but then it's come down dramatically since then. Let's do one more example. So far we've been focusing more on, I would say, descriptive analytics. So different kinds of slices and dices on the data, different metrics using different dimensions, different time periods. Let's look at a more diagnostic query. So let's say I want to find, let's start a monthly total positive cases. And again, this is now for the whole of the US. So it's, so I do, so again, the data set is from January to October. So the positive cases were from almost 0 to, yeah, it's increased dramatically. And one thing we're seeing is that the number of cases in July was much higher than in June. So let's actually see that, right? But let's dig a bit deeper. Maybe ask a question: why is the positive cases in July 2020 more than June 2020? So now this is an example of a diagnostic analysis where automatically it's going to come up with a more detailed analysis or drill down of possible reasons for why the number of positive cases increased in July compared to June. So in this case, it decided that the most interesting dimension was state. So it says that a reason why July was much worse than June is because Florida, Texas, California, Georgia, Tennessee were the 5 states that had massive jumps in number of positive cases. So this is an example where we're seeing how the system can automatically do a more detailed analysis of variances, something which might have taken a human at least half an hour or so, maybe several hours in some cases to come up with. So to stop the demo at this point, switch back to the slides just to conclude this talk. But hopefully this gives you an overview of our vision of conversational analytics, how people might just be able to ask questions in natural language in a very conversational, chat-based manner and get relevant insights from data sets. And we believe this is dramatically going to change the way organizations work and how they handle and use data. So, with a tool like this, we believe people will no longer have to wait for data. They can interact with data anywhere using the mobile phone, using their own favorite collaboration platforms like Microsoft Teams or Slack. They can slice and dice the data as they choose and not be bound by the constraints imposed by a dashboard or report. They can, one thing which I didn't show, we can also do group chats where several people can be chatting with each other on the data. And they can collect the findings and act on the data and keep repeating the whole process of analysis and decisions. Some of the key things that at least our system does, which are critical to make this happen, are automatically connecting different kinds of databases. So we want this to be a single portal, a single platform where people can start chatting with the data across different data sets. So they don't have to worry about where any given data is actually present. We can also do this on Microsoft Teams and other platforms. So we can ask questions in natural language. There are interactive chats and boards, can include analyses and predictions. And our system tries to guide the user along the conversation. So remember, this is a conversation between the user and the system or the data, and not just a sermon. And finally, some of the key points about conversations is that we want the ability for users to be able to drill down conversationally. So that's just like any conversation, we can drill down and get deep with the people that we're conversing with. We want the same thing to apply for conversations about data. Another nice thing about a chat-based interface is that the whole transcript is now present, which means that you can recall how you actually went about certain analysis and what got you to give an insight. So that's the end of my presentation. We'd like you to imagine the future of work and the future of how people interact with data. I encourage you to try out our system at cubo.ai. There's a free trial available where you can set up an instance, connect it to your favorite data sets, or even upload a data set, connect it to a database, and configure it and start asking questions immediately. Thanks for your time, and see you later.